Hi, this is part of our series of guides on measuring stuff. In this case, noise, and specifically, what are octave bands and why are they used? Octave bands are used to split the audible frequency spectrum into smaller segments or bands, allowing you to identify noise levels across different parts of the frequency range. Octave analysis is often used in noise control, hearing protection selection, and in environmental noise assessments. When you measure the sound level on a sound meter in decibels, you get the overall level, which might be frequency weighted to account for how the human ear hears sound, but it does not tell you how that sound is made up. Single octave band measurements, sometimes called first octaves or 1-1 octaves, are used when the frequency composition of a sound needs to be determined, but the level of detail does not need to be very high. It is no coincidence that you find octaves on a piano and in music generally, and an octave span on a piano behaves the same way as octave measurements on a sound meter. Moving from one note on a piano to the same note an octave higher will double the frequency of that note. An octave band measurement on a sound meter will measure the level of all those frequencies or notes, so each octave band will be double the frequency of the previous one. They are made up of the lower band limit, a centre frequency, and an upper band limit. The graph on screen now shows an example of a typical octave band spectrum, where each bar is an octave band and the height of that bar is the decibel level of sound in those frequencies. You can see that the level at 2 kHz is greatest. And now here is a short clip of octave bands being measured on a sound meter, where you can see them responding to the sound. Although octave frequency bands are defined and named by their centre frequency, the characteristics are quite broad and internationally standardised. The simple method to calculate the span of each band is a multiplication of the centre frequency. Calculating the lower band limit, you take the centre frequency and multiply it by 0.707. To calculate the upper band limit, you take the centre frequency and multiply it by 1.412. So the band limits for 4 kHz octave band are made up of a lower band limit of 2.83 kHz, a centre frequency of 4 kHz, after which it's named, and an upper band limit of 5.65 kHz. Now let's take a look at third octave bands. These are mainly used in environmental noise and noise control applications, and provide a further in-depth look at the noise levels across the frequency spectrum. Each single octave is split into 3, providing a more detailed view of the noise content. On screen now, you can see a screen grab from a dBAIR sound meter in third octave view. As you can see, the lines of measurement are narrower and there are lots more of them. The upper and lower band limits can be calculated in a similar way to octave bands, by multiplying the centre frequency by 1.122 for the upper limit and by 0.891 for the lower limit. You must remember that overall frequency filtering, such as A-weighting for the correction to human ear response, can be applied on top of octave or third octave bands if required. So the octave results you see can come with or without A-weighting applied. It may be important for the application in question that you make sure you use the right one. It is possible to measure half octave bands or 6th or 12th octave bands, although these are less common. There are plenty of applications for octave and third octave bands, and many modern sound meters on the market today will offer these as an option. Some examples of applications where understanding the frequency content of your measurement is necessary are noise reduction and control, building acoustics, machinery and product testing, octave band hearing protection assessments, where some sound meters today include software which calculates your hearing protection assessment for you. The Castle DB Air even includes a database of hearing protection to help select the suitable ones straight from the meter. We hope this little insight into octave bands has been useful, and if you want any further help then please do not hesitate to get in touch. Also, don't forget to subscribe to our channel to see many more videos like this one. Have fun and bye for now.